for U4L18, which I should have open right here. No, apparently I don't. There it is. Okay, the do now is a Google form. Again, this is not graded, just something to kind of warm you up to using simulators, and then we'll do a more in-depth simulator thing. The bullet point has a link to the simulator. This is just a simple one. It'll look like this. You should be able to run it on your computer. I assume it doesn't require Flash, but if it does, or you can't get it to work, let me know. And the Google form is about 5 questions, 2 multiple choice, and 3 free response. So go ahead and work on those. I'm going to time this for 8 minutes. Let me know if you have questions or if something doesn't work, and we'll come together after 8 minutes to check in. Go for it. Kiddos, 8 minutes has elapsed. I'm seeing 7 responses, so just need 2 people to wrap up. You can keep working and submit. How did that simulator work for all of you? Did it run? Cool. Yeah, I like it because it's nice and simple. We're going to use a more complicated one in a second. But to take a look at some of your answers here. So I'm seeing a little bit of confusion about the different options for what was happening in the very beginning, where you just have the moon go around, right? The options were circular, elliptical, decaying, or escape in terms of the types of orbit. And so what I want to emphasize is, if you imagine we've got our little body right there, right? If you've got something like that, that is sort of perfectly evenly distributed, what kind of orbit is that?
Circular.
That is circular, right? Then what if you had it where it looked like this, but it was kind of a little wider, almost looks like a little eyeball?
Elliptical.
That's elliptical. Okay. Anyone want to guess what decaying looks like?
It just keeps going on out.
Yeah, that decaying I think of more like this, that it is moving inwards, right? That it's eventually going to crash into whatever source of gravity it is, whether it's a star or a planet. That's decaying. Going outwards would be called what? Anyone know what it's eventually going to do?
Escape.
That would be escape, right? Where it's going outwards. I'm not entirely sure. I mean, maybe you could use decaying. I don't know. Decaying for me, I think of it as getting closer, not further away, and eventually falling into it. So for the first one, you should have seen circular for that question, and then explaining why that is, knowing our equation, right? With our m1, m2 over distance squared. Anytime the mass, if I made that number bigger, the mass on top, anyone want to guess what's going to happen to my value for gravitational force, F?
And it gets higher, stronger?
It also gets higher. Yep. And so that's why the moon gets kind of pulled in a little bit more, because now the gravitational force acting on it pulls it in closer. And I assume this is kind of a simple simulation. So I assume the tangential velocity, though, is still maintained, so it still continues to fall around the planet. It looks like most of you were getting that. You understood that then when you increase the mass drastically, you get an elliptical orbit. But then what I'm seeing for your answers for the next question about what do you notice about the speed, in the elliptical orbit, a lot of you are noticing that it's moving faster, which is great, right? The elliptical orbit look more like this. But anyone know where it's moving faster in particular?
By the Earth.
Yeah, when it's closer to the planet, it moves really fast, right? And then when it's out here, it goes slow. And you can literally see in the animation, it goes whoops around and then slowly back in, right? It's like it's getting slingshot out, and then it's slowly getting pulled back inwards towards that source of gravity again. So that's sort of what that was getting at. And it's something we've discussed a lot with elliptical orbits already. And then the last question was just why does it then float away? And it's exactly the same as that previous question, right? Now we have drastically reduced the mass, so there's much less gravitational force and the tangential velocity takes over. So looking like we're feeling good about that. Sort of some of the basic stuff we covered from that last part of chapter 5. Questions on any of that? Okay, then before we get into the more in-depth PhET simulation, I want to give you a chance to review the homework assignment, which was chapter 28, questions 1, 3, 5, 7, and 9. And I know I made a mistake on the assignment. I set it for no submission. So if you weren't able to find a place to submit your book, that's because I made a mistake. I fixed it this morning, so you can now submit a link to your digital notebook that I can grade. And so do that if you weren't able to do it before. But any questions here that you found confusing or left blank? I feel like number 5 in particular was kind of a harder one to figure out from the text, just because you really had to kind of work your way through that. They have like 2 pages of the nebular theory. People feeling good about number 5, according to the nebular theory, did the planets start forming before or after the sun ignited? What you guys get?
At the same time, right?
It all started happening at the same time, but in terms of they all started at the same time, right? But did the sun ignite right away?
No, it had to build.
It didn't. And so technically, the answer to number 5 would be that they started forming before the sun ignited. So you're right, the textbook says everything started forming at the same time, but the sun wasn't ignited right at the beginning. It was beginning to form, and then the gravity got so powerful that it started explosions and collisions inside of the star, and that's when it ignited itself. So that technically the planets were forming before that. Mm-hmm. Kind of a little detail. You kind of had to get through the whole paragraph of that section of the chapter to that they touch it right at the end again. All right, nothing else? Okay. Then our next task is sort of a repeat of the do now, where I am again going to have you run a simulation and answer some questions on it. And you're going to do a little Flipgrid that we're going to test fire screen capture using Flipgrid, which we'll see if it works. If it doesn't, there's solutions for it. This one is a PhET simulation. It'll look like this, and you're going to be using, there's model and to scale. You're going to be using the model version. And as you can see here, there's a bunch more controls, much fancier than the one we were using for the do now. You're going to be first using this third simulation down from the bottom where it's just Earth and the moon. And then you'll be using this one second from the bottom where you've got sun, earth, and moon. And there's some cool things you can see as you switch on gravity and velocity. But anyway, the questions will give you the instructions. It's just a short little Canvas quiz. It's actually just 4 multiple choice questions. And then sort of a free response. But what it is a PhET or a Flipgrid assignment where I want you to screen capture, post a video of your screen, and you can do this on Flipgrid by, rather than hitting the record button, there's like 3 dots for more options right next to the record button, and one of the options is screen capture or screen recording. It's a beta program that they run. I test fired it a few times and it worked. If it doesn't work, you can use QuickTime on your computer. If you have a Mac that's running Mojave or later, if you hit Command-Shift-5, it'll just automatically pull up a screen recording mechanism, which is pretty easy to use. So I have videos here that'll walk you through all of it. So here's a short video on how to use the simulator, a short video on how to record your screen using Flipgrid. Instructions are also in the quiz. So I'm going to give us 20 minutes to work on this. And I'll be here listening if you have questions or if something doesn't work. Please check in with me, especially with the Flipgrid and stuff. So 20 minutes, go for it. And again, check in with me if you're confused by anything. All right, kiddos, 20 minutes has elapsed. Let's check back in. I know some of you are still working, but that's okay. Again, anything you don't get done, we'll just roll over into homework.
Edward's power went out.
Uh-oh.
So okay. He doesn't know when he'll be back, and he will make up the work at some time.
Cool. Yeah, just shoot him. Just tell him to work through the tasks. That'll always be up there like normal. So, cool. Perfect. Thanks for letting me know. That's too bad. All right. Yes, I am seeing now. Looks like we've got 5 respondents at least to the quiz. So again, if you're not done, it's okay. You can keep it open. Just wrap that up. I know the last question you just checked done or whatever, and it's fine out of the 9 of us here. But so what do you think of that simulation? I think when you switch on the path, when it shows the Earth, Moon, and the Sun, that to me was so cool, seeing how the moon kind of actually like corkscrews around. Looks like a little flower almost, right? And that was one of the key questions to answer. So just to kind of break down the statistics here really quickly. A lot of you got that the moon makes a full rotation in what amount of time?
27 days.
Anyone know what we call that? There's 12 of them in a year.
Moon phases?
Mm-hmm. They're called the moon phases, but they're also the basis of what? What do we have 12 of in a year?
Months?
Yep. So the months are often based on the moon phase, right? Every month starts with, and I think the timing does differ a little bit. Usually have no moon going to a full moon. In fact, we are now in a very special month. Islam, Muslims, is a religion that is very moon based. And does anyone know what month it is right now?
May.
It is May. But does anyone know what significant month it is in for Islam?
Is it is it the month where they
It's one of the
I
5
forgot.
pillars of Islam, if you've learned about Islam at all. This is Ramadan, which is when they fast.
Okay.
I was gonna freaking.
Yep. So it means that it's sort of a way of sympathizing with the poor and people who don't have food. So they do not eat while the sun is up, which is pretty intense. So, or drink water or anything. And so they can only eat at night once the sun is down. They do this for a whole month, so a whole moon cycle. And so again, I lived with a Muslim family in the Peace Corps. And man, when the month was almost over, some would just wait for a radio broadcast that Ramadan's over and they would celebrate. But others, they had to see the new moon just begin to form, so they'd be out there every night looking at the sky, looking for the moon, so they could stop fasting. It was pretty crazy. But anyway, kind of interesting to know that a lot of human behaviors and religion are based on the moon and cycles of the moon. As well as our calendar. So everyone got that. It's pretty cool detail that Earth actually rotates on its axis a little bit too. You don't see this in a lot of simulations, but technically the Earth is also moving in response to the moon. It's very, very slight, but it's kind of cool to see that detail in there. You all saw that when you switch off gravity, the moon just shoots off like a sling. And again, that's because there's no gravitational pull holding it to Earth anymore, but it still has its tangential velocity, right? That doesn't have anything to do with gravity. Does anyone know if that happened, if it was able to escape Earth, at least? I mean, let's say that we didn't turn off all gravity, but if it escaped Earth, anyone know what would pick up the moon eventually? What's the other really big thing in our solar system that
Jupiter.
Jupiter's big, but there's something even bigger. Something has an even bigger gravitational. Yeah, right. It would probably fall into orbit around the sun. It might even fall into the sun. I don't know. And I think that's what you guys played with towards the end of this, playing with this FET. So yeah, I really think that little corkscrew motion of the moon is really cool. It's actually not as simple as just the moon having a consistent velocity around the Earth. It's almost like it's getting sort of dragged. It like shoots around the Earth behind it, and then once it cuts in front of the Earth, it sort of slows down and stops as the Earth continues to rotate, and then it continues to go again. So a different perspective kind of changes up the way the velocity arrow. Do you guys notice the velocity arrow kind of like kept waving back and forth, and it get bigger and smaller, bigger and smaller. So it's kind of interesting to see the detail there. Checked out a few of your videos, which look pretty good. So what was the trick? Anyone know, like, what was it that allowed you to get the moon to fall away from Earth, but to not hit Earth or and eventually fall into the sun or escape? What was the trick?
I just made Earth's mass like super small, so the moon would they couldn't grasp onto each other as much, and then I shifted the sun's mass so it would pull the Earth but not the moon, and the moon flew off.
Mm-hmm. Anyone else have a different strategy? That's what worked best for me too, and a lot of it was almost timing as well in terms of where the moon was when you made your adjustments. But yes, reducing Earth's gravity so that it sort of lets go of the moon, and also increasing the sun's gravity so that it either sucked it towards it, or if you timed it right, the moon would just shoot off, but you wouldn't lose Earth. So, and it's fun to kind of continue to play around with that app a little bit. The to scale version is crazy to show you how small these planets and stars actually are and how far away they really are from each other. It's kind of cool to see. All right, any other questions or comments on that? And again, if you don't have it done, it's okay, don't panic. You can continue that as homework. So now what I want to move on to is drawing and doing some calculating of orbits on paper. Sorry I don't have an out of our chairs activity today, but this is the closest thing I could do. What I'm going to walk you through really briefly is you're going to be drawing two things. You're going to be drawing an ellipse using 2 focal points and drawing some kind of like wider circle like that. And then what we're going to do is calculate what's called the eccentricity. Eccentricity is a really fancy geometry word for how round is your ellipse, right? It's how close it is to a circle. Circles have an eccentricity of 0. They have no eccentricity. They are perfectly round, right? And so the closer to 0, the rounder, or I should say circular, your ellipse is, the further from 0, the more elliptical it is. The way to calculate this, it's all based on the center, but we have a problem here because right now I just have my two foci, which we use to draw it, which you'll see. So does anyone know what's an easy way to find the center of my ellipse, or what I have to do? What could I measure?
The halfway point between the two foci.
Bingo. So just measure the distance between the two foci and then divide by 2 to find the halfway point. So that would be my center right there. And then it's a little weird, but eccentricity, which I'll represent as E, is calculated with this weird equation. We call it C over A, like that. Pretty sure I'm remembering this correctly. This is new to me as well. Yep, C over A. And so C is going to be a smaller number, A is going to be a larger number. And so what A is the center, the distance from the center to one of your focal points. That's your A value, center to a focal point. It doesn't matter which one you use, they should be equidistant. The C value is the center all the way to the outermost edge right there. That's your C value. So you'll get a very small number for A, you'll get a big number for C. And so doing a small number divided by a big number, it's going to give you 0 point something, right? And then again, closer to 0 means your ellipse is round, very circular. Further away from 0 means it's very elliptical, okay? And I give you instructions on how to do this. I have a whole other video on how to do this, so I just wanted to introduce that idea. We're also going to draw a circular orbit, and that I hope is a lot easier for you to do the math with. So here's your circular orbit, and what I want you to calculate for that is the circumference. Does anyone remember from geometry what the circumference of a circle is?
Thing around it, how long it is around.
Yes. If I were to take that circular edge and flatten it out, how long would it be, right? And very good. Bailey, how do I calculate circumference?
Pi r squared, right?
That I think is the area. Circumference is simpler. It's just 2 pi r.
2 pi r.
Yep, that's circumference. And again, I've got instructions on how to do this. Does anyone know what pi is? Just the first 3 numbers.
3.14.
3.14, right? Anyway, I've got instructions on how to do it, and I have a little video on what I want you to do. You're basically going to make a drawing that'll look something like this, where you've got a circular orbit, an elliptical orbit, and you're showing your eccentricity and your circumference. So just to share with you, but you can see all this. This is number on the tasks list. This is number 5, activity, drawing orbits. And so there's my little instructional video, which I encourage you to watch. I think it's about 6 minutes long, maybe a little bit longer. And then I've also written out all the instructions. So if you don't feel like watching the video, you can just read through the instructions. It should be pretty good guide to what I want you to do. And then there's just a picture you need to take a picture of what you've drawn with your various calculations and submit that to an assignment that I have linked at the very bottom there, drawing orbits. So I want to come back together at 3 o'clock. And so that gives us about 12 minutes to at least work on this. So I'll time for 12 minutes to at least get you started. And again, it's okay if you don't finish, it can just roll into homework. There's no other homework that I'll be giving you this time. So 12 minutes. Let me know if you have questions or you can't figure something out. Go for it. All right, kiddos, that has been our 12 minutes. Let's come back on into the room. Again, it's okay if you're not done. This will just be the homework that you have to work on as well for Tuesday. Anyone brave enough to hold up their drawing, show how far they got? Did we even get like the ellipse down? Hey, we got started. Most of you able to find string or floss or something like that to use? That's been the one challenge. No, nothing. Okay. Well, you can get creative, or yeah, use the necklace. That might work actually. Yeah, there's different things you could use. So, all right. So I just wanted to conclude with a little. Some of the feedback I got from the midterm comments was asking for more games and stuff. I guess you guys have been using Kahoot and quizzes and stuff in other classes, and I haven't been doing that. So as a ticket to leave, let's try using a Kahoot. I have only done this once with my advisory, but I assume it's pretty straightforward through Zoom.
Oh, Mr. Haight.
Yeah.
I'm sorry. My power went out.
Oh, yeah.
Randomly. I'm sorry about that.
Yes. When, let us know. So yeah, no, I'm glad you're back here. So yeah, anything you missed, just work through the tasks that are posted there on Canvas, and you should be fine. So
All right.
Whoa, all right, why can't I get a link? How do I get a link to this? Assign the challenge, create. Sorry, you guys can tell I did not think this through. I thought this would just pull a link up and we could do it. Okay. So it looks like here's the pin you can use. Am I not able to pull it up in Kahoot though, like the others? Sorry guys, you're my first attempt at this, so. Let me see. So my question is
We can try joining the game using that pin. Maybe I'll start.
Yeah. So question is then how do I see it though? Like, because usually someone has to administer it, right? I'm not seeing an easy like play. So let me go back.
I don't know how.
Yeah. Okay. Well, let's hit play. Oh, I think I see the problem. I clicked assign.
Oh, I started it.
Yeah.
Yeah.
I started it as well.
I can start it also.
Okay, I think I've got it going here. So, okay, there we go. There's the music. Okay, are you guys able to join what I've got on the screen? Looks like the pin's there. Still listing 0 players though.
Yeah.
Hey, all right, there we go. All right, now there's 8 of us here, so let's. Anyone having trouble connecting? Hey, there we go. All right, in the interest of time, let's just go for it. And again, it's my first time doing this, so. All right, what is tangential velocity? Aha, good. Most of you got it. That is indeed moving parallel to Earth's surface. All right, Cesar in the lead. True or false, the moon orbits Earth at a consistent velocity, same speed at all times. Very good, it is false, and we saw that in our simulation today. Cesar in the lead still. Increasing the mass of a planet would cause satellites orbiting it to. Very good, orbit a bit closer. Again, we saw that in our simulation. Julia on fire, here we go. Who's gonna be able to topple Cesar? Looks like he's rocking it. What is eccentricity? Very good. It is not a measure of how social or outgoing you are. It's a measure of how round an ellipse is. Awesome. All right, let's see. Victor. Oh, all right. Oh, Bailey overtook. That was sudden. All right. Cool. Okay, boy, some pretty fun goofiness there. All right, kids, I apologize for taking you a few minutes overtime. Your only homework is to complete any of the classwork you didn't get done here in class today, which is the making sure you finish that Flipgrid post and the Canvas quiz on the PhET orbit simulator, and have a picture of your drawing submitted for the assignment. Thank you very much. Have a good weekend.
Hi, thank you.
Hang around here if anyone's got questions or needs to chat about anything.